Hi, everyone. Can everyone hear me okay? Yeah, perfect. So thanks for coming to my talk. And yeah, we'll be talking about calling APIs and being able to monitor them by using Guzzle. If you don't know me already, my name is Liam Hammett. As you probably could tell from the fact I'm wearing a hoodie, I've got a shaggy beard, and I'm at a PHP conference. I'm a developer by day. But for those of you in the front row, might be able to see a bit closer. I've got some bags under my eyes, and I'm also a developer by night, because it's just so hard to stop coding when you have an idea and you just want to keep doing it. So in my day job, I work at a publishing company called Future. Now, 20, 30 years ago, a publishing company like this may have been doing mostly one thing, writing articles and publishing them and printing them into magazines that you then buy at newsagents. But over the last decade or two, that's changed quite significantly. And now a huge part of the business is not just printing magazines, but it's online as well. And so that's what I deal with. I deal with running the digital publishing platform that we have. And we run many brands. We've got hundreds of brands on this platform, all covering all kinds of things like tech and gaming and women's lifestyle and gardening and photography and lots of things. So you might not recognize the name Future, but you might recognize some of the brands below that are running on our platforms. But what exactly is a publishing platform? It's kind of something I've struggled to explain to people before, but I think I've got a really good explanation that everyone here is going to get behind. Who here's built a blog before? Okay, less people than I expected, but still about half the crowd. So that's basically it. So we've got a blog here, we've called it the Telemetry Times. You have a basic page, you've got like a list of articles in a database, you show the articles on the page, you have the ability to click on one and you can view the article, and that's basically it, right? It's really simple. But what if you take this simple blog and you start to add a search bar to the top? You could do that in your main database, you could do that in MySQL or Postgres or MongoDB or whatever you're using, but while they can do it, they're not necessarily optimized for that. So maybe you're going to look and try to use something like Algolia or Apache Solar or Elasticsearch, and you're going to be calling an API to power your search. Then you scroll down on the article, and you see at the bottom here, we've got this thing that says, sign up and pay to continue reading. And whether you like or hate paywalls, they are like a valid business thing. So we've got people writing articles, and some people have come along and said, well, we're going to do really in-depth, complex stories that we're going to want people to pay for. So, okay, we need to add that feature. And we actually need to do two things there. One, we need to be able to authenticate people and have accounts. So we could build that into our own application. But we could also use something like Auth0 or Firebase and use an API, again, to power our authentication. And then we've got to manage the payment side of it. So you'd probably be thinking about using something like Stripe or PayPal, or maybe some combination of different things depending on where in the world people are trying to pay from. So with that alone, we're now calling an API for authentication and an API for payments. You scroll down again, and we've got a comment section underneath the article. And again, you could build that into the database yourself. But actually, there's a lot of stuff about comments that you probably aren't thinking about, especially when you're operating on the kind of scale where you're delivering millions and millions of articles to people per day, like people are viewing these articles millions of times. So we can't just have a plain discussion box that you can type in and submit. We need to link that up to the authentication as well. We need to think about what happens if someone types a bad comment. We need some way to report that. We need to notify the author that their article has been commented on. If someone replies to a comment, we need to notify them of that as well. There's a bunch of extra little things in there that you probably haven't thought about initially. So we might be using an external service like Discuss or Viafora in order to implement comments on the site. And then you scroll down beyond the comments, and we've got this related article section. And again, you could do that really simply. You might make an SQL query to just pull in the latest articles that are sharing the same tag or something. But that's not necessarily going to be the best stuff, because if you're serving millions of these pages every single day, any little optimization you make to a block like this to make it more likely that someone is going to click through and start reading another article, that means they've got a much higher chance to engage with the site, to view ads and affiliate links and get involved in the commenting and stuff. So instead of just displaying the latest articles from the same tag, maybe we're going to go ahead and import our articles into a vector database or hook it up with some analytics and have a service there that we can call via an API that is going to give us a much more powerful and useful list of related articles. You scroll down beyond that again, and we've got a newsletter form. So people might enter their email address into that, and now they're going to get sent an API to MailChimp or Amazon SES or some other service. So you can see how we started with this really, really simple blog that was just making articles, but we very quickly, like in just 3 minutes of talking, grown to this weird graph of lots of different APIs that are calling other APIs, and some of them are calling each other. And this is still a very basic example. But what happens if you have a company that has become a multi-billion-dollar company and you've taken over an entire industry? Uber published this on their engineering blog a couple of years ago, and this is a list of all of the different APIs and microservices that they're calling throughout their applications. And it's absolutely insane. Uber does so much stuff, and they really leaned heavily into microservices. So they're calling APIs throughout all of these things. So what do you do if you have your application here, but something's going wrong down here? How do you even start to think about tracking that and knowing what went wrong and how you can fix it? It's really difficult unless you know the right tools to use. Now, for these tools, we're going to talk about the concept of observability. And observability is the act of looking into your application, being able to see what's happening inside it, not just at the code, but when it's actually running, what is going on. And this is pretty commonly agreed that there's 3 fundamental pillars that make observability. The first one is something I hope we all do, is logs. Adding a line for a log into your application, it'll tell you exactly what happened at a certain point in the code. The second pillar is tracing. And tracing is kind of like logs, but instead of telling you what happened at a single point in time, it's going to tell you what happened over a span of time. The very third pillar are metrics. And metrics are a little bit different to both logs and tracing because typically they're not used to show a single event. They're used to capture a lot of events and show you the kind of average results over lots of time. And we're going to be looking at all 3 of these today and how we can utilize them. But all 3 of these are actually underpinned by this concept of telemetry. So telemetry is collecting the data. And if we think about a car, for example, you might have a gauge in your fuel tank to be able to tell how full it is. You might have a thermometer in your engine to be able to tell how hot your engine is getting. You might have a sensor that's detecting how many times per second your wheels are turning so it can calculate how fast you're going. But when you're in your car and driving, you're not going to be sticking your head out the window and putting your hand on the bonnet and going, ooh, it feels pretty warm. You're not going to be looking at, oh, it's 1, 2, 3, 4, 5. Oh, yeah, the wheel's spinning 66 times per minute. That means we're... No, you don't have that. You're not looking at the direct telemetry data. You have an observability dashboard in front of you. And that's what we want for our applications. So we're going to expand on this and look at the tools that we're going to use for this. And the first tool I really want to talk about is this thing called OpenTelemetry. Now, OpenTelemetry it's kind of new. It's been around for a while, but in the last couple of years, it's really, really picked up. And it's a couple of things, but first and foremost, OpenTelemetry is a set of standards that you can use to define your logs, traces, and your metrics and transport them. And that's really powerful because it means that you're not locked into just one specific vendor or one specific tool to do any one of these 3 things. You have a set of standards that you can use that are interoperable between many things. So you can have many different programming languages, many different dashboard applications, all creating and ingesting the same data and showing it to you. You're not locked into any one thing. And so the second thing I really like about OpenTelemetry is, even though they've defined this, they've also got a bunch of packages and extensions and SDKs that you can install for basically any language you can think of. So we're going to look at them for PHP, but if you're also writing applications in Golang or someone else in your company is writing stuff in JavaScript, you can also get them to install OpenTelemetry and start recording data and pushing it to the same place as your PHP telemetry. And the tools we're going to be using to actually view this are, for logs, we're going to be using a tool called Loki. For traces, we're going to be using Tempo. And for metrics, we're going to be using Prometheus. We're going to go over these in a bit more depth later. But Loki, Tempo, and Prometheus are basically these databases that is going to store all of our logs, our traces, and our metrics, and allow us to query it later on. But instead of having 3 separate tools to be able to view all this, we're going to be using a tool called Grafana, which is a dashboard that's going to be able to show us all of these 3 databases side by side and build out dashboards and graphs and useful things so that we can see what's really going on with our application. And there's 5 tools there. I don't want to have to explain how to run every single one of those. But luckily, Grafana have put together a really helpful Docker image called Grafana OTel LGTM. And you run that with Docker, and it's going to set up all of that stuff for you. It's going to set up Loki and Grafana and Tempo and Prometheus and an OpenTelemetry collector. And it's all configured and set up. You don't have to do no extra work to get that working. So we're going to run this. And we're going to have 2 ports exposed, really importantly. So port 3000 at the top there is going to be where we're going to view our Grafana dashboard. And port 4318 is the OpenTelemetry collector. So this is where we're going to be sending our logs from our application. We're going to be sending them to this port, and then it's going to handle the rest of it for us. So to get started in PHP, we need to require a couple of composer packages. The first one we're going to include is the OpenTelemetry SDK, and this is going to give us a bunch of classes and utilities to start recording this data for us. And the second one is the exporter. And the exporter is going to take all the data that we're collecting in our SDK, and it's going to export it to that collector that's running in Docker. There are a couple of extra things you can do. So if you're using the SDK manually, that means you're adding lines of code to your application in order to choose what you're recording and what data is important to you. But if you install this OpenTelemetry extension and install one of these auto packages, so for example, here we're installing OpenTelemetry Auto Laravel, that's going to hook in and automatically start recording telemetry data for things like eloquent queries and logs and anything else. If you're doing stuff in your application already, you can install this, do no extra work, and you're going to have telemetry data being collected, and you don't even have to think about it. And that's not limited to just Laravel either. They have packages available to work with any framework like Symfony or Cake PHP. If you're really interested in how you're using your native PHP functions like curl or PDO or anything like IO when you're getting and writing files, they have things that can log that information for you and record how long it's taking and when you're doing it and if it's blocking anything else in your application. They also have a bunch more that cover basically whenever any PSR interface is used or so many other things. So there's a link at the bottom here to go and view the registry that they have. They have a registry of maybe about 30 or 40 different packages where you can just require them into your application, just like the Auto Laravel one. Do no extra work, and you're going to get a ton of benefit from it. There is a little bit of setup work involved in actually using the exporter. It's really simple, though. You can go to the OpenTelemetry documentation, and they're going to walk you through setting up the instrumentation. It's basically just making sure that we're pointing our exporter to that port in Docker. But by default, most of it's going to work out of the box. So how do we call the APIs in our application? We're going to be using Guzzle. I think everyone here has probably heard of Guzzle before. I'm seeing a lot of nods. It is an HTTP client for PHP. So you require it through Composer, and then you get this kind of interface where you have you can create a Guzzle client, and then you can make a request. So here we're making a GET request to the GitHub API. If you want to, you can pass through some post parameters in JSON format or whatever. You can pass through extra headers if you want to. But what it gives you is this really nice response object where you can really quickly check the status code, the headers, what the body copy is. And you don't really have to think about all of the curl handlers and all the other stuff you might be used to if you're not using something like Guzzle. And it's such a nice interface that it's become basically the gold standard of calling any kind of API in PHP. But where it gets really powerful is that when you create your Guzzle client, you can pass through a series of configuration options. For example, you can say, hey, I want you to follow any redirects. Don't give me a 300 response. Give me a 200 response after the several redirects that it might follow. Another thing you can give it is saying how long you want it to wait before it starts to time out and just thinks the other server that we're calling isn't really doing anything. There's a ton of different options here, and they're really powerful. We're going to focus on one of them today, and that is the handler. Now, a handler is actually a stack of basically functions and callables that we're going to go through. So whenever we make a request, it's going to go through everything in this stack in turn. So that's where we're going to be defining our middleware. So we're going to create a middleware, and we're going to push it into the handler stack, and then set that up in our Guzzle client config. And when we're talking about middleware, I really like to think about onions. And it's not just because the more layers you peel back, the more you want to cry. It's that when we're thinking about onions, they have layers, and middleware are like layers. So if we think of the very core of this onion as the core of the Guzzle request and response, it's like the actual logic that's making the request and returning the response. Middleware let us add layers. So if we've got a happy little application here, and we're making a request to this, then every single step of the journey, we're going to be going through one of the middleware that is in our handler stack. And when we do this, we have access to the request object that we're making. So we can modify the request object if we want. We can add extra headers. We can also start to collect telemetry data using the OpenTelemetry SDK. And as we're doing that, it's going to be completely transparent to the application where we're actually using that Guzzle client, because we don't have to think about collecting that telemetry data now. The middleware is doing it for us. It's really nicely abstracted. And so when we get to the core of the request response cycle, what is Guzzle going to do? Well, it's going to have to send it back to our application, but it's going to be doing that through those layers as well. So every single layer that it goes through, it's giving us an opportunity to be able to record that response data and record telemetry on that as well. So we have an opportunity to record all the request and response data, and the request comes back to our user, and we're really happy, and we haven't had to think about anything else when we're using the Guzzle client in our application. So let's build out this middleware. It's basically a callback that returns another callback. Maybe a little bit confusing, that's just how Guzzle does it. But the core thing we need to know is that this next variable here is going to be invoked, and that's going to represent the next part of the chain, the next layer in the onion that we're going through. So that might be the next middleware, but that might also be the actual core of Guzzle that's going to give us the response back. But instead of giving us the response back directly, it's going to give us a promise. And this promise we can then use to chain some additional logic. So if we add this then function, that will accept two parameters. The very first parameter here is a callback that has the response object that we've got. So that's going to be for any successful HTTP response. If we have a 200 or a 404 or a 500, that's all a successful HTTP response. The second callback, though, is going to be called if we have a transfer exception. So that's going to be if we hit the timeout that we configured before, or if there was something like an SSL error when we were trying to connect to the API. So now we've got a place where we've got access to the request, and we've got access to the response, and if the response didn't happen, we can do something else as well. So we can start to collect telemetry data in these places. So we'll clear that up a bit and just focus on the middleware itself. We can start really simply by just adding a log line. So we're going to add a log line here saying we're making a request to this URL. And that's a quite simple start. What I think enough people don't do with logging, though, is adding additional context data. Most logging tools are going to let you pass through a structured array of keys and values where you can add additional data. And that's going to be really useful later on when we start to search through our logs and try to find information about them. So here we're going to record the request method, the host name, and the path. I'm also going to give it a client name because I think that's going to be useful later on. So if we're calling our search endpoint, for example, I'm just going to call this search API. You might want to call this Algolia or Elasticsearch or Apache Solr or whatever API you're calling. You probably want to give it an appropriate client name. For now, I'm just going to abstract this and make it a variable outside the middleware, just because we want these middleware to be reusable. So I'm going to keep it here for simplicity right now, but if you're building this in your own application, you probably want to abstract this into a function where you just give a client name and you get the whole middleware back. And that way you can keep reusing it for different APIs that you're calling without having to set this up every time. So we have a log for the request. Now we can come down and add a log for the response. So we're logging the client name again, and we're logging the response status code. Really useful and simple. But what's difficult is we now don't know what response this is actually related to for the request, because these are two separate logs. So if you're viewing the logs on your local development environment, you might hit refresh on your application and you see in chronological order all of the logs come in. But what happens when you have a production application that's getting 3,000 requests per second? They're going to be coming in weird orders. It's not going to be chronological. They're not all going to be related to the same request that you're making. So that's not necessarily the most useful way to do it. So one way we can improve that is just by moving all of this request information into the response log, and we get rid of the log that we're making when we're making the initial request. So when we're doing this, now we have a single log that has a bunch of information. We know exactly what request happened and what the response was. So if the response was a 503 for this and we got a server error from the API, we can look and we go, oh yeah, we were calling this path when we got that 503. Maybe we can look into it like that. And again, for the transfer exception, if we don't have a response object, we can add the same request data, but we don't have a response to add the status code. So what a lot of people like to do is add a status code of 0 for this kind of thing, because 0 isn't really a valid HTTP status code, so it's very obvious if you see this that something went wrong that wasn't necessarily related to HTTP. And since we have an exception here as well, I'm going to add in the failure reason, because we can just get that from the exception. And that might help us debug later down the line if it was a timeout or an SSL error or something else happening. At the top here, I'm going to make sure that I am logging at an info level, because most of the requests that I'm making are info level things. They're just additional information. They're not necessarily critical bits of information I need to know every single time. Because when you have an application running, getting 3,000 requests per second, if you're logging everything, you're going to be logging up your log server so quickly. So what we're probably going to do is only start to log errors or critical level logs in production, but have the opportunity to turn on info level logs if we really need to for a set amount of time. So up here, this is info. Down here in the exception, I've started to log this as an error. So this is a different error level. And that means that we can make sure we're always going to be getting this logged in production. Now, up the top again, even if we get a successful HTTP response, maybe we want to change that to an error log if we get a 400 or a 500 back from the server that we're calling. But for simplicity, I'll keep it like this for now. So we've got our logs. We're recording them. OpenTelemetry is exporting them into Loki. How do we start to view and inspect these logs? Well, again, like I said, local development, you might tail your logs and just watch them in chronological order come in, but it just doesn't work at scale. So this is where Loki comes in, and we're going to take a look at this with Grafana as the dashboard. So we're going to come into Grafana, and on the left-hand menu here, we're going to click on Explore. And there's a query section here where we're going to start to look at typing out a query. So first of all, we're going to type in our service name. I've called our service the telemetry times because that's the name of our application. And it's starting to show all of the logs from our application. And again, we can push data in from multiple different applications into the same database and see them side by side. But if we just want to view logs from our one application, we can filter by that. And now I can also update that query to add more stuff. So here, I'm updating that to say, well, I only want to see logs where the client is the commenting API. And now I can filter that again and say, well, I only want to see the commenting API when we've got a 500 response code. And so you can start to see from this, we can build up queries using that contextual data as if it was data in a regular database that we'd use. And we can drill into this now. We can see, well, we are still getting some 500 errors from that commenting API. We can see it on the graph here and on the timeline. So down here, where we've got our logs displaying, we can expand that and start to look into them. And it might be a little small to see now, but we have all of the context data that we were recording here, along with information like the severity level of that particular log. So you can see how suddenly we've got a way we can inspect all of this data really, really clearly and at a glance. But the next thing we need to look at is tracing. And like I said, tracing is similar to logging, but it records something over a span of time. So we're going to start with our Guzzle middleware, like boilerplate again. So we're going to build this out as a separate middleware to the logging. We're going to start off by resolving the tracer provider from OpenTelemetry's SDK. That just lets us create a tracer, and we're going to give that tracer our application's name. So in this case, it'll be the telemetry times again. And from then, we can start to build a span. So this span that I'm building, I'm giving the name of, whatever the client name was, plus the word request, just to make it super clear. So for example, it could be comment API request, or if you're being a bit more specific, it might be saying something like Amazon SES request, so that later down the line, we can really clearly see what exactly we're recording the data for. And when we're recording this, we can actually add additional context data just like we can with logs. So I'm going to set an attribute here and log the request method. But instead of giving it just the name of method, OpenTelemetry has this concept of semantic conventions. So instead of just giving it an arbitrary name, which you can do, if you're doing something like logging an HTTP request or a call to a certain API or something on Android or whatever, they have this class which has a bunch of constants which you can refer to, and that will make sure that throughout all your applications, through different languages that you're using, you can have the same kind of attributes and the same names so that you can refer back to them and know exactly what you're looking at, instead of everyone calling something different. I have an update available. Going to skip that for now. So we're coming back, and we have here this request method, and we're going to swap that out so that the key is actually using that, the trace attribute's semantic conventions name. And there's a bunch more here as well. So I'm going to add a bunch more and record as much information as we can about the request. Really notable is stuff like the request body size and the user agent that we're sending, because that can be really, really useful later on to figure out what's going on. And then, after we've set all that up, we can start our span. And everything that happens after this line of code is going to be treated in our telemetry as if it's part of that span. So we can come down into where we're making a response, and we can record additional data as part of that span. So we're going to record stuff like the response status code, the response body size, and so on. And we can also set a status on these spans as well, which is going to help us later down the line. When we're visualizing this, we're going to see if something's green, it's successful. If it's red, it wasn't successful. It's just going to really help us visualize and see what's working and what isn't, and where our applications are going wrong later down the line, which we'll see. And then we can end our span, because now we're not recording everything as part of that span. Anything that happens after this is just back in our normal application. So everything that's happened between starting the span and ending the span, in our case, is just making the request and recording the response. So that's going to come in really helpful later on, and we're going to see how. And we're going to see it with Tempo. Tempo is the database that's storing our tracing data. And we're going to be using this and looking at it through Grafana once again. So we're going to come back to Grafana in our Explore view, and instead of having Loki as our data source, we're going to select Tempo because we're wanting to look at telemetry data, tracing data instead. So we can start to add in a similar query here, and we'll filter to tracing data for our application. And it gives us a list here of all the different traces that we've recorded over our application's lifecycle. And we can come in and we can inspect that, and we can see what spans we've got inside a trace. And if we click inside a trace, what is really, really useful is it opens this panel to the side. And what I care about most is down here at the bottom right, where we have the list of spans that were being recorded here. It might be a bit hard to see at the back, but the spans that are being recorded here are SQL queries. And we didn't do anything with SQL queries. We were just touching Guzzle. But this is what the OpenTelemetry auto Laravel package is doing for us. It's hooked into Laravel, and it's going, oh, whenever an SQL query is being made by Laravel, I want to record that as a trace. So with this view, for free, with no extra effort, we are able to see how many SQL queries are being made across a request in our application, how long they're taking, if they were happening at the start of our application or at the end of our application, or if they were happening inside another span that we were recording. And that is so, so useful to get for basically no extra effort. And we can also click into these as well. Again, might be a little bit hard to see, but we have all the attributes that are being recorded there against that span. And in this case, it's recording what database query was being made, what database it was being made against. And that's really, really just useful for free. There's also a button above there that says you can view the logs for this span. And if you click that, it's going to show you all of the logging lines that happened inside that span. And that works the other way as well. So if we come back to our Explore view from Loki and we're viewing our logs, when we're viewing our context data, OpenTelemetry has really helpfully added a span ID and a trace ID for us. And Grafana has seen this and goes, oh, well, there's a trace ID here. There's a button you can click if you want to view all of the things that happened in this trace. So we click that, and we can see at the right-hand side, it opens the same tracing panel, and it shows us all of the spans that happened, including all of these SQL queries. But now we can start to see in this request, we were making a call to the PayPal API service. And we can see exactly how long that took, because that's the span that we're recording. We chose when it was starting and when it's ending. And we can see everything that happened inside that span. And if that service itself was also implementing OpenTelemetry, you can use that to view what happened inside that other API as well. So if it was pointing to the same tempo database, that is. So in this case, we have like a PayPal API microservice that's handling all of that for us. We call that, and it's sending the tracing data back to the same database. And we can see what SQL queries were happening inside that other API that's not the one we're working on. And so if you think about this, and back to the graph we had before, where how do you track down what's happening, 5 APIs deep in a microservice architecture like Uber, well, this is how we can do it. We can start to see really deep into it. And again, we can start to expand one of these, and we can see all of the different attributes that we were recording as part of the span. So we've got all this information readily available, but that only really helps us for a single request. So we need to look at metrics. And metrics are going to help us figure out the overall health of our application. I have a little confession in that I didn't quite get the OpenTelemetry metrics exporter working for this demo. But since we were going to be using Prometheus anyway, I'm just going to quickly explain how to use Prometheus. So this is how it would work if OpenTelemetry exporter was working and configured absolutely fine. Our application has the exporter, and that would be pushing data into the collector that's running in Docker, and the collector would give it to Prometheus. So we're going to simplify this a lot with a bit of magic. We're just going to have Prometheus pull the metrics straight from our application. The way that we're going to do that is by setting up a configuration, and we can pass this into our Docker image that we're running to tell Prometheus, hey, every 15 seconds, I want you to call localhost 8000 on the metrics path. And then every 15 seconds, Prometheus is going to make a GET request there. And it's going to come back and go, OK, give me your telemetry data, give me your metrics. And it's just going to work. So to make that work, we're going to quickly use this PromPHP package. And that is going to basically be the same kind of thing as recording data through the OpenTelemetry SDK. So we're going to set it up very quickly. We're going to create a collector registry, and we're going to give it some kind of data store. So in this case, we're using Redis. And then we're going to set up our endpoint for that /metrics thing that Prometheus is going to be scraping every 15 seconds. And so the collector registry that we just made is going to be able to give us all of the metrics that we were recording. So it gives us a really helpful way. We're just going to display that in a plain text format on that page for us. So this is how you start to use it. So we have a collector registry somewhere in our application, somewhere in our middleware. And in this case, we're going to get or register a counter. We're going to give it the name of our application. We're going to give it the name of the counter that we want. And we can also give it some help text. And then with a counter is a number that can only go up. So we're going to call this inc function to increment the number by 1. So we call this once, and we're going to get this information here. So we have the help text at the top. We have the type and the name of the metric that we're recording, which is the namespace and the name joined together. And then at the very end of that second line, you see it says counter. So that's the type of metric we're recording. So we call our application once, and we trigger that code. And it says, well, 1. We've called it once. We call it again, and we go 2. And then 15 seconds later, Prometheus comes back, and it's going to look at this file, and it's going to figure out what's happened. So it's going to go up and up and up. And you're noting we're not storing the time that any of these things changed. Now, Prometheus is a time series database, and the way that it's working is every time it scrapes something, so every 15 seconds that we've configured, it's going to calculate the difference between this and the previous time that it scraped. And so it's going to go, oh, within these 15 seconds, there were, what, 1,200 and something requests. Or not requests, but this metric has been recorded that many times. And there are more things that Prometheus can do. It doesn't just handle counters, but there are 3 primary things that Prometheus and OpenTelemetry metrics can do. So counters just go up. Like the number of requests you're making to an API is never going to go down. You're never going to make a negative number of requests to an API. Further down from that, we have a gauge. And a gauge is similar to a counter, but it has numbers that can go both up and down, or just be set to a certain value. For example, the number of active connections you've got to another API isn't always going to be static. As you're making more requests, the connections will go up. As your connections are resolving and you're getting responses, your connections are going down. And the third type is called a histogram. And a histogram is a little bit more complex. It's actually like 3 kinds of data that's being recorded at once. So the primary thing is it lets you split information into buckets. So in this case, we're going to record the duration of the request, how long it took from making the request to receiving the response. And it's going to record 2 values, primarily. It's going to record the number of observations, so the total number of times that we made this request. And it's also going to count a total number of observations. And the observation is the number that we're trying to track. So if we're trying to track the request duration, we're going to be observing, in this case, 0.4. So the request and response took 0.4 seconds to come back. So if we call this once, we're going to get a count of 1 and an observation of 0.4. If we call it 3 times, we're going to get a count of 3 and an observation of 1.2. So it's not really super useful for tracking individual requests and things that happened. But over time, this is going to let us calculate the average amount of time that a request is taking, because we can take that observation total and we can divide it by the number of the count that we've got. And in this case, it's going to record a separate metric line for each bucket that we have. So if we're observing something that's taking 0.4 seconds, well, that's going to come into this bucket to say, well, it's taking between 0.25 and 0.5 seconds. So rather than recording exactly how long it took each time, instead we're just going to be able to see, well, most of the requests fit into one of these buckets. There's also another really important thing, which is very similar to buckets, and that's called labels. So you can give a list of labels to any of these types of metrics, and you can pass them in. And any unique combination of these labels is then going to be recorded as a separate metric so that you can filter down to that specifically later on. So this is what that might look like, where you can see all of these are doing the same thing. This is the total requests amount that we've got here. But we've got a bunch of unique labels at the end. So we're getting a bunch of different values that we can inspect separately instead of just one big number. So we could, if we want to, go in and filter into, well, how many client requests were we making to the auth service for logging in or logging out as 2 separate things? And that's really, really powerful. I do want to note on this, though, this example here, if you pay attention to these lines, all of these have IDs in the paths. So we have article IDs and comment IDs. And that's not necessarily the best thing to record metrics for, because that means every single article or comment that we have that has a unique ID is going to be having its own separate metric line. And that can be fine, but you probably don't want to be recording separate metrics for every single thing in your application because you want to have a general overview of things. Prometheus can take a lot of data, but if you let it get out of control, you run into this n+1 issue that you might be familiar with SQL. So let's build our last middleware of the day. We're going to create those labels like we did before. I'm going to put path in here, but maybe think twice about that depending on what kind of APIs you're calling. We're going to start to record the time before we've made the request, because that lets us, after we've made got the response, we can compare that time to the current time, and now suddenly we have a value which is the duration of the request. How long did it take from start to finish? We can also add on labels once we've got the response, because being able to filter by the status code that we got in a response is really helpful. And then we can start to record this data. So this is the same code as before. We're observing the duration. We're giving it a bunch of labels. And that's really helpful. But you can't just stop there on that one thing. We don't only need to know about the request length, but you can record so much other data as well. You can record stuff like the request and response body size and see how much data you're sending over the wire. You can see how much time you're wasting on doing like DNS lookups or connecting to services. Maybe you need to run your application from another location if you're calling an API that's only available in one location. But we got that data. Let's look at Prometheus and see how we can view that. Again, we're going through Grafana. So we're going to come back to our Explore view in Grafana. We're going to select Prometheus as our data source at the top left. And as we start to type in our query here, Grafana is really helpful. It's going to give us a list of all of the metrics that we have in that namespace. So in this case, I've got one called Guzzle seconds count. So that's a number of times that we've recorded this metric. And if I search for that, it's going to give us this graph which shows a straight line that's going up because, like I said, counts are only ever straight lines going up. So it's not super useful, but Grafana is really, really helpful. It gives us this information that says, well, this is a counter. Maybe instead you want to know about the rate of that counter, so wrap it in the rate function. So we click that, and it's going to automatically change our query for us. And now we're getting a rate of that metric with an average over 1 minute. And now this graph down here isn't just a flat line. It's showing us an average of every 1 minute how many requests were being made. But down here, it's showing us how many requests were made to each unique label, which isn't necessarily the most useful. So what we can do in our query is we can come up and we can wrap that into some function, and it's going to add all of those values together and give us a single line on this graph. So we can see in total, on average, we're making about 1.6 requests per second to every API. It's also not the most useful. But if we add this by client clause to the end of our query, now it's going to filter by a single label. Or we could give it multiple labels if we want. So now we can see there's fewer lines on this graph, but the labels that match each of these lines are going to be only the API clients that we're calling. Really helpful. We can also change the average that we're calling. So instead of 1 minute, we can change it to 5 minutes, which is going to smooth the graph out a bit. So depending on the length of time you're looking at and the kind of information you're looking for from your graph, you might have a different average. You don't want to type that query out every time, so Grafana lets you add that to a dashboard, which you can see at the top right. I'm not going to go over making a dashboard, but this is one I've made earlier in classic Blue Peter fashion. And with this, we've got a bunch of different graphs that's showing us the total number of requests we're making, the number of failed requests we've got going to our APIs, the number of requests by client, really, really useful things to see at a glance. And down here, we're not limited to just graphs. I've got a table that's listing all of the different API clients we've got with a bunch more information. And I click on one of these, and I've got another dashboard that's going to help me really inspect what's going on with a single API. So that all is really useful. There's a bunch of other useful things in Grafana as well. So at the top right, you can set how often you want that graph to refresh. So you don't have to sit and refresh it manually. You always see a real-time update. You can also filter the amount of time and when you want to see metrics for. Over here, I've set up an average. So if I want to inspect things over a 1 minute average and see those really spiky graphs, I can do that. If I want to view a more flat graph over a longer period of time, I can change the average to over 30 minutes or something. And I can also change the client as a variable. So all of these things are set up in the dashboard, and they are going to let us change all of the graphs that are on the dashboard with a single click. We don't have to go and figure out how to make a different query. We have a really powerful dashboard that's going to give us all the information that we want without much effort. One other thing I really, really like about Grafana is this concept of annotations. So I'm going to touch on that quickly. Here you'll see we've started to get dotted lines on some of our graphs. And in this case, these dotted lines are representing when I've deployed my application. So in my deploy script, I'm calling an API to Grafana that's saying, OK, I want to make an annotation here. And so we can start to see metrics in relation to what's happening outside of our metrics that we're recording. So here, if we move on time a little bit, you can see I've started to have my requests go up. And that happened right after I made a deploy. So I might be thinking, OK, I've made a mistake in my deploy. I'm calling things a few times over. So I go and look at that. I'm going to change the average to 30 seconds because it's just happened. And that shows us, actually, we're making about 3 times more requests than we were before that deploy. So it's given us a way that we can see something's going wrong. And we can go and fix that in another deploy. And you see after we've made the other deploy, our request duration and our request amounts have gone down again. So we've got a way that we can see what's going on in our application overall and be able to inspect that and fix it really quickly. The very last thing I want to go over is we don't want to be looking at this graph all the time manually and having someone 24/7 on it. So Grafana also lets you set up alerts. So again, we're going to come over to the sidebar, go to alerting. First of all, we're going to set up a contact point, which is going to be where this alert should be sent. So I've set up one here already to send me an email. But if you look at the other integrations, you can automatically have alerts sent to Slack or Google Teams, or if you're using something like PagerDuty and you've got someone on call, you can page them through that. You can also send a webhook, so you can do basically whatever you want when an alert is triggered. How do you trigger an alert, though? I've made one already. So here I've got one called payments failing. So my query is checking if the requests to my payment service are, it's going to give me a percentage of successful requests. So later on, I can come down and I can start to see, well, in this threshold, if my payment service is having less than 90% successful requests based on the metrics that I was recording, I want an alert to happen. But I can also come down and set some evaluation behavior. So in this case, I only want it to happen if, for a consecutive 5 minutes, there have been these failures. If there was a blip for 1 minute or 15 seconds, I don't necessarily want to get woken up at 4 a.m. to go and fix that. But if it's happening for 5 minutes consistently, then I want to know more. So now we've got a way that we can get alerted when something is happening in our application, be able to go into a graph and inspect what's happening, see where it was in relation to, did someone else make a deploy at a weird time that broke it? And then we can dive into our traces and our logging and everything else and start to inspect it. So we've set all that up, and I've chosen my contact point, and I can choose a custom message if I want more information. You can make as general alerts as you want, or you can make really specific ones for specific metrics you care about. So we talked about 5 different tools here: OpenTelemetry, Loki, Tempo, Prometheus, and Grafana. And it is a lot to take in. I'm going to publish the demo application I used for this on GitHub right after this talk. And I'm also going to publish a couple of articles explaining how to set this stuff up in PHP. So if you want to, you can find me on X or Blue Sky or Mastodon or on my website and get that information later as well. Thank you very much.